Hi, my name is Caitlin Brock and I'm a neuroscience major at the University of Kentucky. And today we're going to be showing how to use the Lobster model for electrophysiological recordings. So the first thing is we'll be demonstrating with our lab mascot, Ed, here. And one of the most important things to remember is when you're holding the lobster, obviously the claws are going to be very sharp, so they should be banded when you're holding the lobster. And also you have to be careful about holding on to the tail right here because these are very sharp. So when we're using this preparation, we're going to fold the tail underneath. And then so the first thing that we're going to do is we will euthanize the lobster, and we will not show that here, but we will demonstrate with the mascot Ed here. So we're going to cut right here, and then you'll cut this way and split the brain, and then you can take the head off. So this is our lobster, the live one, and as you can see, these sides right here are very sharp, so we're just gonna tuck the tail under. So the next part is going to be to remove the claws right here and here, and you can save those and eat those. And then we will be cutting open the gill chamber, the cuticle around the gill chamber here, and removing that, and then you can remove the gills and remove the internal organs in the thorax. One is going to use the legs later on for electrophysiological purposes. They can cut off the legs first and remove those and dissect those first. If not, the legs will need to be removed for our preparation as well. So here we have our lobster preparation once the head has been removed, and as we described, we cut open the cuticle around this gill chamber and removed all of the internal organs from there. So now what we're going to do is just cut off this first leg here. So after you've finished cutting up here, you can grab the tweezers, and as you pull this piece up, you can cut along here, cut the muscle to remove this top layer, and then you will end up with something like this. And you may have to cut the nerve away here at the end to detach it, and then you will end up with the nerve here that runs all the way up, and you may have to gently cut away some connective tissue to get it out of the way of your nerve. And as you keep going up, you will cut the connective tissue, and as you get here towards the top, it might be a little harder, so you may have to cut some of the muscle, but once we get that in saline, we'll be able to clean up the muscle. Since the joints have extra connective tissue, it gets a little harder over there. Place some pins on the connective tissue here to hold it down so it won't all go up into the suction electrode. So now we're going to be recording from the leg nerve of the lobster, and we're going to be recording compound action potentials. And so we dissected our preparation and put it in a dish with 2 suction electrodes around that nerve, and you can measure your nerve using a small ruler to measure the millimeters. You might want to stretch that nerve out when you measure it for recording conduction velocity. Here's the stimulator, and it's going to this stimulator isolation unit where we can change the direction and control the gain and the amplitude, and that is connected here to our preparation. So this is a way to record the recruiting of neurons. So as we change the voltage, we increase that up to find max amplitude, which means that we are recruiting all of the neurons in the nerve. And now we can see that over here as we increase the voltage, we reach a max amplitude. And there I'm still increasing the voltage, but the amplitude's not changing. And then as we turn it down, we can decrease that response. So now that we've looked at recruiting neurons, we're going to look at the refractory period. So how we do that is by applying two stimuli, and that'll be at different rates of delay relative to each other, and as those get closer together, we can see that the amplitudes will decrease, and it'll get smaller and smaller as they get closer together until it disappears completely, and that's how we can measure our absolute refractory period. So to start with, they're really far apart, and as I decrease the delay between the two, we start to see the second response appear and get closer and closer to the first. And those are getting smaller. As you can see, the second one is getting smaller. And now we're just going to change settings. And you can see those side by side is decreasingly getting smaller. You can measure the time between the two stimuli, and that will give you your absolute refractory period. So we have just removed the legs, and now we are going to remove the swimmerettes down here. We are going to show how to use many different preparations from one lobster. You can actually get up to 15, so that makes it especially useful for educational purposes. One that we already mentioned was the nerve in the legs that we can record from. Another thing that we could record from is here, we will also show you on the live animal, is the superficial flexor muscle, and we can record in there intracellularly. If you do not have the ability to perform intracellular recordings, you can record using a suction electrode from the motor nerve. So here we have our intracellular electrode inside of the superficial flexor muscle, and we also have a ground wire over here. Our intracellular electrode is only around -37. As we can see here, these are spontaneous quantal events going on. These movements here are due to the stumps of the pleopods moving. These are evoked responses here. And these down here could be quantal events, but they're probably smaller EJPs. And you might see negative ones down here because there are inhibitory junction potentials. If one is recording intracellularly or using the suction electrode, by brushing along the outside of the cuticle on the same side of the preparation that you are recording in, you can change the activity patterns of the recording. This can also be affected by neuromodulators, so by adding serotonin to the preparation, we could also change the activity patterns. This is the third root that we are going to pull into the suction electrode. It went to the muscles right there. So here we have our setup with our suction electrode, and that third root is through the suction electrode here, and that is connected to an extracellular amplifier, which is then connected to our computer. And you'll be able to see that when I brush along the side here, it'll change the number of spikes that we see. So here we have some of our recordings, and you can see right here is where we brush the side of it, and we do have some extra noise back here from where we brushed it, but there are an increase in spikes as compared to without brushing it. Another preparation that we will be doing is the sensory nerve that runs from the MRO, the muscle receptor organ, around to the ventral nerve cord. And we can cut this nerve here and pull it out through a suction electrode, and then by bending the abdomen, we can record those sensory responses. This is also similar to the muscle spindles in mammals. With the scalpel, we are going to very gently cut the membrane here. And we will do that along each of these segments, as you can see. And then we are going to come in and break the rib, being very careful not to cut the ventral nerve cord. Now we can cut and remove the thorax here. So now we are recording from the MRO, and the ventral part has been dissected away, so it's easier to add potential compounds and that sort of thing. So we just pulled the segmental nerve into the suction electrode, and now I'm just going to move the tail. As I hold it still, we don't see a lot of response here, but then as I move it slightly, you see more of a response. And then when I move it quickly, and this is holding it in a bent position, and then holding it flat, and this is going to be bending it a lot and holding it there. So we can also show you another preparation where we record from the segmental nerves that are in each segment along here. It is best to keep those nerves intact when you are dissecting them because it's easier to remove the connective tissue. We already cut this one as we previously described, but we can work around that. And those segmental nerves come around and connect to this ventral nerve cord, and we can remove those and put them in a dish for recordings. On the animal, there are 5 segments, and we can obtain 5 from each side of the abdomen, 5 segmental nerves from each side of the abdomen, and within each of those nerves there are actually 3 roots, root 1, root 2, and root 3. Root 3 we will not be worrying about because that connects to the muscle fibers that we had mentioned recording from earlier. But we will focus on root 1 and root 2. So really that could give us about 20 preparations just from one animal. It is important to be careful when removing the nerves for your recordings. You don't want to crush those in the middle by holding them potentially with your tweezers. You could crush them and damage them. Instead you can hold them by the ends, and later we can remove the damaged ends. Then we will take those and put them into a dish like this one, and we will fill them with lobster saline, and we can pin the connective tissue to hold the nerve. This is a Silgar coated dish. So what we did was cut this segment here, and then we cut on both sides of the membrane while we pulled the rib back on one side. We gently cut the articulate membrane around the rib on both sides and slowly pulled that back. It'll look like this up here once it's finished. There is the first root. The second root just got cut, and it goes around down to there. What we have done is carefully cut away some of the muscle along the cuticle, and we will pull that away. And you can see the nerve on the other side. We're going to cut it here away from the ventral nerve cord, and then we're going to cut it again along here, and we will take that out and put it in the dish. The one on the left is the second segmental nerve, and the one on the right is the first. Once we have the nerve dissected, we can put each end into a suction electrode, and we can record from one while we stimulate with the other. And using this, we can record compound action potentials, recruitment of neurons, conduction velocity, as well as pharmacological changes and environmental changes such as temperature or ionic differences. So now we are going to show another way to remove the segmental nerves as a preparation. And so the first thing is that the lobster is going to be euthanized the same way as before, by cutting the head and splitting the brain. We will separate the cephalothorax from the abdomen. So once the head has been cut and the brain has been split, and the abdomen is separated, we will then cut off the swimmerets right here. So then we will cut here and split the ribs, and then we will cut and remove little sections on each side to isolate the ventral nerve cord. One can cut each rib, and as each rib is cut, tiny sections on the side can be removed to expose the ventral nerve cord but not yet sever the segmental nerves. Now that the ribs have been cut, you can see the ventral nerve cord along the middle, and you can even see some of the segmental nerves extending outwards. You can also see the 6th abdominal ganglion as well. So now we're going to go in and cut each of the segmental nerves to isolate the ventral nerve cord. After you've cut the segmental nerves, you can close your scissors and run them along the underneath of the ventral nerve cord just to make sure that you've cut all the segmental nerves. Sometimes the third root can be still there, or you forget to cut it, so you might have to make another little small cut. As well, make sure that you're careful because it can still tail flip and you don't want to cut yourself on the sharp tail flip. When removing the ventral nerve cord, it's good to use a tool to lift it up. You can also take your tweezers and close them and put them underneath and pull it up like this, making sure that you're not pinching it. So this process may take 2 people, one to separate and then one to make the cuts. But once you're finished, don't pinch the nerve, just place your tweezers underneath of it and lift it up, and then place it into the dish. To make sure it's submerged, you can just gently press it down with your finger. Now what we're going to do is split the abdomen in half. So we're just going to separate it along this midline, and if we stick to the midline, we won't be damaging any of the segmental nerves. And when you look down here, you can see that we're just going to cut this muscle right in half along the midline. And then we're going to use scissors and cut the tail off right here, so that we can make it into 2 halves. If we've done that, we're just gonna flip it over and cut right down the midline so we can separate out our 2 halves. And now you just have your 2 halves. So now we're going to carefully cut the membrane around the rib. If you have to, you can grab onto the end of the segmental nerve with your tweezers. We can always recut it, but you will follow the segmental nerve all the way around here to these back muscles, and it will connect all the way to the MRO, where it'll branch off to those different muscles. And then we will place our preparation in saline. So here you can see the segmental nerve. And if you look down here, you can see that it branches, and if you pull it back a little bit, you can see that it's pretty long. So one can try and cut up here as close to this muscle as possible, however long that you want that to be. So here you can see the segmental nerve that we just dissected out and the ventral nerve cord. And the ventral nerve cord is very long, as you can see. It's about 7 centimeters, and our segmental nerve is about 3 centimeters if you stretch it out. We could have this longer if we dissect it a little more. We can also use a suction electrode to record the compound action potentials from the different segments, because each one will have a different number of neurons. So this is the standard nerve recording chamber from ADI Instruments, and as you can see, the ventral nerve cord is very long on here, so we can record compound action potentials. We could stimulate here and record here. Since the ventral nerve cord is also so long, we can perform multiple recordings, so we could stimulate here and record here as well, to measure conduction velocity. So while you're performing your recordings, you'll want to keep the ventral nerve cord moist with saline, but keeping the saline below these metal wires. Here is the segmental nerve in comparison that we took out. So with this one, we could stimulate with these two and record from these two. We are hoping that this video could be of some help and potentially replace the frog sciatic nerve as a preparation, because we can record similar properties in the lobster, but potentially get more preparations out of one animal as compared to the frog.